Hi, so in this example, we're going to look at doing a join of two tables, one a Dask.DataFrame, which is quite large, and another one, which is a Pandas data frame, which is going to be quite a bit smaller. This is a common case problem. It's fairly easy to do computationally. We're just going to walk through how to do it with Pandas, then with Dask.DataFrame on a single machine, then with Dask.DataFrame across a cluster. So I don't actually have a data set here, so I'm going to make a fake data set. I've got to have many different products that all have ratings and values. These products are going to be into 1,000 different categories. So my products have the unimaginative names of AAAA, AAAB, and so on, all the way down to ZZZZ. And I'm going to group those into categories, into about 1,000 different categories, just completely randomly. So product AAAA is in category number 143, along with several other products. I'm going to have fake data. So we have our products and they're in categories. This is going to be a fairly small table, so we're going to use this table a lot, this table dimension. This is going to go throughout our entire data set. This fits in memory very easily. This is the thing against which we're going to join. We're going to have much larger tables that are going to look like the following. We're going to have our product, the same product as before, along with some rating and some value. I'm choosing just sort of random numbers here. This is indicative of what we sort of see in the wild, but obviously real data will be different. Okay, so this function fake data takes in a number like 5 and produces a data frame with that many values. We're going to do this both to make a large data frame and to make several data frames with Dask.DataFrame. So what we want to do is we want to merge our fake data set with this table of categories. As we're using the pandas merge function, which affects an inner join in this case on the product column. So again, this is all just straight pandas. People are doing this for years. It's really well appreciated. It's a common case problem. So now we're going to do the same thing with Dask.DataFrame. So normally we would load in our data through something like the read CSV command, pointing to HDFS or S3 or just a local file system. I don't have any data locally, so I'm going to just use our previous fake data function and the Dask-delayed function to create a Dask data frame of many different files or partitions. So you can ignore all of this. This is just making a slightly larger fake example. We have 10 different partitions, each with 10,000 rows. It's not very large. It's just for playing around. So the object that we have here is a Dask data frame. And this is the same object you would have if you were loading your data in from HDFS or S3. I'm just making it in this fake way. So that object, looks a whole lot like a Dask data frame. It looks like just what we just had, and it has the same API. So we're going to use actually the exact same merge functionality we used before, but now instead of using it on a pandas data frame, we're going to use it on a Dask data frame. So we're going to merge our Dask data frame df against the same pandas data frame we were playing with before, this smaller fits in memory dimension data frame, and we get again this new category column added on to our Dask data frame as a result. So again, exact same syntax, exact same workflow, works exactly the same, but now in parallel. When we called head, we just looked at a small sample of the data just to see what was going on. But let's go ahead and do some computation you might want to do on our full data set. So here we're going to use the Dask data frame API, which is exactly like the pandas API, to group by the category. And then get out the rating column, so this rating that says whether or not a product is good or bad, and then compute the mean per category. Then we're going to get the 10 largest results, and actually then compute the answer. So here we go. That just happened in parallel with all of my cores on this one machine, and we find that category number 611 is particularly well rated. And so here you go. You can imagine how this might be useful in your own data set. Okay, so that was using Dask.DataFrame on a single machine. And now we're going to use the exact same thing, but on a cluster of computers. So I've stood up a cluster elsewhere with 20 different workers. Each worker has 16 cores. And we're going to make now just a larger example of that same data frame. Now, instead of having 10 partitions, it's going to have 1,000. And we're going to go ahead and do our exact same computation. We're going to do the join with this merge command. Do a group by, compute the rating, etc. I have here on the left a dashboard of our cluster. You can see our 20 different computers happening. And over here on the bottom, we have I'm going to show the nice progress of our computation. So it's happening both, we're seeing both progress in the notebook and over here on the left. This is showing us our computations as they're occurring. And also down here, we're seeing what each core of our cluster is doing over time. And right now they're doing a lot of merging. And in maybe 10 or 20 seconds, it'll finish up. So we're also going to look at the entirety of our computation here. So let's go ahead and look at this full history. This is showing us all of the history of our computation, everything that's happened so far. So on the left, we see these bands of purple, and that's our computers actually making our fake data. So this is the function is fake data. So on the y-axis here, we have all our different cores. There's around 360 different cores. On the x-axis, we have time. On the left, we're seeing it, making a bunch of fake data. And then we're seeing over here in this green, these merges. Let's zoom in a little bit. And the merges are taking, looks like something like 3,000 milliseconds. So it takes about 3 seconds to affect the join on any of the data frames. These red bands here are moving the data, moving the dimension table between machines. So those are data transfer. And you'll notice that after every set of merges, there tends to be a little cluster. Let's see if I can zoom in here. A little cluster of group by operations. So we've zoomed in now a bit. So these group by operations are happening around 200 milliseconds, or sometimes even just 20 milliseconds. So if we think about our computation holistically, we see that the merging operations here are taking 3 seconds, while the group by is taking 200 milliseconds. So really we should be focusing on the merge to make things go faster in the future. In particular, I suspect that this computation is bottlenecked by the merge because we're using object dtype. So Pandas handles text by using Python objects, and that's a little bit slow. So we could maybe accelerate our computation in the future by using something like a Pandas categorical. And I suspect that would make our computation go, roughly 10 times faster. So that's it. Again, we've seen us using the Pandas merge functionality, both in parallel on a single machine and across a cluster.